Hello, computer science students. Today, in this video, we're going to talk about unification and some rules behind unification, which is really the core of Prolog functionality. Now that we've talked about variables and ifs and ands, we can start talking about unification and make sure we understand all the rules. So for this example, for this demo, I have a really simple database here that basically it defines father. And it says that Adam is the father of Bob, Bob is the father of Charlie, Charlie is the father of Dave, and Dave is the father of Edward. So we're going alphabetical down the list here. Then we define this predicate grandfather, which has a variable x and variable z. So x is the grandfather of z if x is the father of y and y is the father of z. Okay, so in other words, Adam is the father of Bob, Bob is the father of Charlie, so therefore Adam is the grandfather of Charlie. And that's the basic operation of this um, data set. And we're going to use it to help demonstrate how unification works. So to start, unification, this is the, like I said, the key part of Prolog. This is what tells us whether a Prolog statement is true or false and whether we can get correct and good answers out of Prolog predicates. So at its core, the very first rule um, is that every constant unifies with itself, any constant or any number. If you'll remember from previous videos, a constant is any word that starts with a lowercase letter. So Adam is a constant, Bob is a constant. So Adam unifies with itself. We can check this with an equal sign. So Adam equals Adam, that is true. It does not unify with other constants. So Adam does not equal Bob. All right. In Prolog, we can also use numbers. So 1 equals 1. This gives us true. 1 equals 2 gives us false. 1 equals Adam gives us false. Okay, so things unify with themselves, numbers unify with themselves, and other constants or atoms, A-T-O-M-S, atoms, um, unify with themselves. So Adam, A-D-A-M, equals A-D-A-M. All right, so that's basic. That's the core of this. The second thing is, if you have a variable, remember variables can start with capital letters. They can actually also start with underscores. We'll see that pop up every once in a while, but mostly we use capital letters. Um, variables can be unified with any other variable or constant. So this return indicates a true return. We found a way to make this work, and it says that the way this works is when x equals Adam. That way, what translates is we're really saying that Adam equals Adam, which is true. Now, one interesting thing here is you can also set a variable equal to another variable. And then this leads to a couple other questions and concerns. So what if we have an and here? So x equals y and x equals Adam. Right, so this is fine. This gives us false though. So if I add x equals Adam and y equals Bob, now we get false. Because x is equal to y, that means x and y are unified. They have to be the same thing. X equals Adam, which is fine. We've now set x equal to Adam. And since x and y are unified, the only way this returns true is if y is also Adam. So if you set y equal to Bob, it does not work. If I set y equal to Adam, this is fine. X equals y equals Adam, and x equals Adam. So within one statement, x has to be defined as one thing. Now this is every query on its own is a unique request. So I could set x equals Adam and get that to be true, and then x equals Bob and get that to work. Every single query is its own query, but if you start querying or asking things that involve the same variable, so x equals Bob and x equals Adam, now we're going to run into problems, right? It's pretty straightforward. Within one query, you can't have a variable be multiple things. It can only unify with one thing, and then it's instantiated and it's done. So similarly, in our database up here, this x variable has to be the same value here. And so this x here and this x here are the same. this z here and this z here are the same, and this y here and this y here are the same. You'll notice, well, I'll show you another example in a second. But first, let's actually run our whole thing, our whole program here. So grandfather, we want to see all the possible grandfather pairs. Now, when I make this query, these two variables don't care what these variable names are. So the x here does not have to be the same thing as the x here. The y here does not have to be the same thing as the y here. Each statement is independent of each other statement. So within this statement, all the x's are the same, all the y's are the same, all the z's are the same. This is a different statement. This is a query. So this x is different than that x. This y is different than that y. This is basically establishing a rule for x's, y's, and z's. And so this is defining a relationship that x is the grandfather of z if x is the father of y and y is the father of z. This is a query where we're saying, what are all of the possible x's and y's that make grandfather true? So here, if x is Adam, then y being Charlie makes this true, right? Because Adam is the father of Bob. Bob is the father of Charlie. Therefore, Adam is the grandfather of Charlie. We also find out that Bob is the grandfather of Dave, because Bob is the father of Charlie, Charlie is the father of Dave. And Charlie is the grandfather of Edward. So Charlie is the father of Dave, Dave is the father of Edward, so we get all three of these as options, and then no more, right? So then we get a false. So there's three ways that we can find any grandfather of x and y in this data set. So that's kind of cool. All this has to do with unification, and I think a lot of the trickiness of unification involves which variables, matter in the. I guess when is a variable unified? When can it be something different? So it's within one statement before this period or this full stop. Um, x is unified with all the other x's, y is unified with all the other y's, and z is unified with all the other z's. However, in a different statement in a query, you can reuse the same variable names and they can mean different things. So each statement's evaluated independently. This is just defining grandfather relationship. This is just a request for who are the grandfathers, which x's are the grandfathers to which y's. There is one extra rule for unification that involves complex terms, terms that basically request themselves. So things like father of Adam, or something to that effect. There's reasons you can use this. There's things to do with this in Prolog. We're going to skip it for this class. We're not going to dive that deep into Prolog. But there is another rule for how you unify complex terms, terms that have other terms inside. If you're interested, please feel free to read up more, but we will not cover it or require it in our labs for this class. All right, see you next time.